The following video has to do with graphing linear relationships. So example 1, using the given diagrams, record the data into the chart. So here we see frame 1, here we see frame 2, and here we see frame 3. So frame 1, it's asking us how many tiles there are. Well, there's only one tile there. In frame 2, there's 1, 2, 3, 4, 5 tiles. In frame 3, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the rest of the frames are not drawn, but we're to look for a pattern. So we'll notice that every time the frame increases by 1, so from here to here it's going up by 1, going up by 1, the tiles are increasing by 4. The independent variable is the frame number. Identify the interval in which the frame number increases. This is increasing, we already indicated, by 1. The dependent variable is the number of tiles. And the interval in which the number of tiles increases is, it increases by 4. So what we're going to do is complete this pattern. So if it keeps increasing by 4, so we're going to keep adding 4. So it's 13, it's 17, it's 21, it's 25, it's 29, and it's 33. So when the frame number increases by 1, so this goes up by 1 each time, the number of tiles increases by 4. That will increase by 4. So now we're going to graph this relationship. So we're going to take these values and plot it on the line. So again, our frame number was our independent. And the number of tiles was our dependent. So when we had one frame, so this goes by 1, 2, 3, so one frame was 1, so it's pretty low here. 2 frames was 5. 3 frames was 9. 4 frames was 13. You'll notice the pattern is going in a straight line. We call those linear relationships. 5 and 17. 6 and 21. 7 and 25. 8 and 29. And 9 and 33. So you can see the points all connect in a nice line. If any point is off, it's most likely because I didn't have my point on the exact area. So again, line of best fits help us make predictions. So I can, how many tiles will be on the 15th frame? I can make a prediction based on my graph. Just follow up on 15 and go across. Oops. There's my dotted line. So from there, let's see what it goes to. It's approximately 57. Example 2, we can explore the relationship of angles in isosceles triangles. In isosceles triangle, the first and second angles have the same measure. So they have the equal measure. Okay. So here, this angle and this angle in an isosceles will be the exact same. Okay. So in 180 degrees triangle, okay, you do 180 minus 10 minus 10 to get the third angle. Again, recall angles inside a triangle always add up to 180. So we have 180, subtract 10 to get the third angle. You get 160. Same thing, 180, you can do, instead of 10 and 10, or 20 and 20, you could do 2 times 20. So 180 minus 40 is 160. Excuse me. Oops, sorry, it's 140, not 160. And again, 180 minus 30 minus 30. You get 120. You'll notice a pattern that every time this goes up by 10, the third angle measure is going down by 20. So we can complete the table without doing every single calculation. So if the angle measure is going to be 40, then this is going to go down by 20, so we have 100. If it's 50, go down by 20, so it's 80. If it's 60, go by down 20, so it's 60. If it's 70, you go down by 20 again, so it's 40. And if it's 80, go down by 20 again, so it's 20. So again, as the measure of the equal angle increases by 10, the third angle decreases by 20 degrees. We're going to take this data and we're going to draw it. So graph the data and draw the line of best fit. Let's do that first. So this is going to be the equal angle measure. In degrees. And this is my third angle measure in degrees. So when I have an angle of 10, I had 160. An angle of 20, I had 140. An angle of 30 was 120. Again, you'll notice a pattern that it's going to be exactly straight line We call these linear relationships. So when your line of best fit can go through all the points, then that's when you know it's a linear relationship. So after I connect all my points, my pattern is always the same. That's how I know it's a linear. I draw my line of best fit now. You'll notice this is a linear relationship. So I can answer that question here. So this is a linear relationship because all the points are on the line of best fit. And that's graphing linear relations. And what is a linear relationship?